In this video, I'll show you how to build the AI Find My Family Guardian in n8n and Home Assistant. It's an automated watchman that activates the moment your grandpa who has dementia leaves home. It then starts a 24-hour watch, continuously tracking their location, and only sends a last known location report with a map link if they don't return within that window. Alright, let's build the n8n workflow that makes this all possible. Our starting point is a webhook. Since n8n's built-in triggers don't currently support reacting to a Home Assistant sensor state change, the webhook is our best option. We'll set the method to post and give it a custom path, like track. Think of this as a unique web address that, once called by an external service like Home Assistant, will instantly kick off our workflow. In our project, a Home Assistant automation will call this webhook the moment it detects that the grandpa's phone state changes to not home. This ensures our Guardian mission starts without any delay. The moment that webhook is triggered, we need to define our mission plan. That's the job of the Edit Fields node. We're using it to do something clever. In raw JSON mode, we're creating a field named loop count, and its value is a list of numbers from 1 to 24. This list is the fuel for our 24-hour hourly tracking operation. Each number represents 1 hour of the watch. To actually use that list, we need the split out node. In the configuration, we'll tell it to split out the loop count field and set the include option to no other fields because we only care about the loop itself. This node turns our plan to check 24 times into 24 actual parallel tasks ready to go. But we don't want 24 checks at once, so to force these tasks into a single file line, we use the loop over items node. By setting the batch size to 1, we create a perfect hourly loop. This is critical. It lets one hourly check go, waits for it to complete its entire journey, and only then does it release the next one. This transforms the instant parallel tasks into a slow, deliberate serial watch. Okay, the 24-hour watch has begun. What happens in the first hour? The first thing inside our loop is the wait node. Its job is simple: pause the workflow. We'll set the amount to 1 and the unit to hours. This is the pacemaker for our entire system, defining our check-in frequency and ensuring we're not constantly polling for location. After that hour is up, it's time to ask the most important question: are they home yet? For that, we use the getAstate node, which I've named phone location. In its configuration, we just select the device tracker entity ID for our grandpa's phone. This node gets the current status. Is it home or still not home? This is our critical abort condition check. The result of that check goes to the if node. This is our loop's braking system. The rule is simple. Does the phone state still equal the string not home? If the answer is false, meaning they've returned home, the workflow shoots down the false path to a call a service node I've named notification. It calls the persistent notification service with a simple message: Grandpa is home safe. The watch is over, and because this path ends here, the entire 24-hour workflow terminates safely. This is our mission complete signal. But if the answer is true, the watch continues. The workflow follows the true path, taking the GPS data from the phone location node and handing it to our AI agent, our AI Geographic Specialist. A simple lat-long coordinate pair is hard for a human to use in an emergency, so we give the AI a precise prompt. You are a GIS expert. Based on the home and current GPS coordinates, calculate the distance in kilometers, convert the current coordinate to a detailed street address, and create a map link. Your output must be a strict JSON object with distance, address, and map link. But AI outputs can be flaky. To guarantee a clean result, we'll enable the require specific output format and add a structured output parser. We give it a JSON example of our desired format, and this is the brilliant part, we enable auto-fix format and assign a second Google Gemini model to it. Now, if the first AI's response is messy, the second AI will automatically clean it up for us, guaranteeing a perfect JSON output every time. With this rich, human-readable location data in hand, the next step is to log it. We use a data table insert row node, which I've named log. We'll create a new table called log trajectory with columns for timestamp, distance, address, etc. Then we just map the data from our AI and phone location nodes into the correct columns. This is our flight recorder, creating a detailed hour-by-hour log of the journey. This log is crucial as it provides the data source for our final emergency report. After logging, the workflow hits the end of the line and loops all the way back to the loop over items node, ready to start the next hourly cycle. Now, let's fast forward 24 hours. The loop has finished all 24 runs. What happens then? The done output of the loop over items node sends out the entire log of 24 data points. We need to extract the most critical piece of information, the last one. For that, we use a code node. It's a simple JavaScript snippet that does two things. First, it finds the very last item in the array of 24 log entries, and second, it formats a clean, detailed emergency alert message containing the final address, distance, timestamp, and map link. This node is our final report editor. And finally, that perfectly formatted message is passed to our last node, which is report. This is another call a service node that calls the persistent notification service, setting its message to the final message generated by our code node. If after 24 hours our grandpa has not returned, this node will trigger, sending that final, critical, last known location report to the family so they can take action. This is the ultimate value of our Guardian system. To tie it all together in Home Assistant, you'll create a REST command in your configuration file with the production webhook URL from n8n. Then create an automation in the UI. The trigger is your grandpa's phone state changing to away. The action is simply to call the REST command you just made. And that's the complete system. A Guardian that wakes up the moment they leave, watches silently, and only alerts you when it's absolutely necessary, armed with the exact information you need. The complete blueprint for this project, including the workflow and all the code, is available for you via the link in the description. Your suggestions drive this channel, so let me know in the comments what problem we should solve next. I'm grateful for your viewership. Every like and subscribe truly powers future videos. Until next time, happy automating.